Hello everyone! Welcome to this webinar about the WS100 precipitation sensor. Thank you for joining us. Today's webinar will be held by Manuel Kreisig and Kurt Nemeth, and my name is Helena Wingert. I will assist them today. Manuel Kreisig is responsible for the technical hotline at Lufft and also takes over the technical training to customers and colleagues. Kurt Nemeth is program manager at Hydromet and is specialized on precipitation sensors. Thus, he knows all about the available precipitation measurement technologies and suitable applications. Now, before we start, let me give you some housekeeping rules. The webinar will be available afterwards as well. We will send the link to the record via email to all who registered. At the end of the meeting, we will take time to answer your questions. Please type them into the question box of the GoToWebinar menu. Before we start the main part, I would like to give you a short company introduction. Lufft exists more than 130 years and develops and produces environmental and industrial measurement equipment. We have our headquarters in Fellbach, which is near Stuttgart in South Germany, and subsidiaries in Berlin, USA, and China. Since 2016, we belong to a strong corporate group, the Hydromet Group. They help water resource professionals to generate reliable data throughout the entire water cycle. Lufft is specialized in traffic, renewable energy, meteorology, and industrial applications, whereas OTT is responsible for hydrological measurement technology. Our agenda for today is to first give you a short overview on the precipitation sensor itself and the technology. Second, we want to show you some connection options and how to calibrate the sensor. Third, we would like to show you the target groups and the typical customer problems. Fourth, we give you some more product info you should know. Fifth, we give you a comparison of all the Hydromet Group precipitation sensors. And last but not least, we will give you some sales arguments in a summary. Now I hand over to Manuel Kreisig, who will start with the technique.
Hello, also from my side, and welcome to our today's webinar about the WS100 and also about precipitation measurement in general. So first I want to show you some key words and also key information about the new WS100. First of all, we have, of course, a unique selling point here, which is the maintenance-free operation of the WS100. So, of course, this is an important fact here, because normally if you talk about precipitation sensors, maybe you know that anyway, so that you have to check them in a different cycle, you have to clean them maybe. There are no moving parts here on the WS100, so there is no need to go there and do something. So that means normally you install it, you configure the sensor, you check the sensor, and then of course you can leave the sensor alone, and the sensor will start to measure and give you reliable data. So that's the nice thing here of the WS100. But of course there are also some other benefits here. First of all, we have direct dome heating. If I talk about the benefits, it is always a comparison which is made with the old sensor from Lufft, which is called R2S. Maybe some of you know this type of sensor. So sometimes today you will see that anyway. So you will see that we will have to compare it with the R2S. So in comparison with the R2S, we have changed the heating. So that means we have a direct dome heating now. That's different to the old R2S. Also, we use a lens inside to focus the measuring beam. I will show you that later more detailed. We have extremely fast measurement, so that means beginning with the first drop of the precipitation event, the sensor will be able to detect this. Of course, a special thing of the sensor also is the precipitation type detection. So the sensor itself is able to detect rain, snow, sleet, freezing rain, hail. Because the WS100 is now also part of the WS sensor series, we have also integrated the standard interfaces here. Normally we use our RS485 interface to connect the sensor here with a special Lufft protocol called UMB, but you can also choose other ones like SDI12, Modbus, and so on. At the end, we have an optimized power consumption for the WS100. Also here, in comparison with the R2S, it is reduced here. And for all the people who want to use the WS100 also solar powered, also this is possible now because we have integrated a special eco mode. Again, I will explain that later a little bit more detailed here. So first of all, the measuring principle. So how does the WS100 in reality measure the precipitation? So what we have done here is we use a Doppler microwave radar with a frequency of 24 gigahertz. Normally the sensor will detect the velocity, the drop velocity, and of course the drop size. And with this information, we can calculate the water amount in the drop, also in the snowflake, for example. Again, here now the comparison. And if you check now this information here, it is the same measuring principle for the R2S. So nothing has changed here. So now you can ask, so why have we now developed the new WS100 sensor? And the main reason is, if you check the left picture, you see the measuring area. And for the R2S, the measurement area or measuring area was conic. And if you go back to the sheet before, you see the new WS100 has a straight measurement area going to the sky. And that's the main new feature and benefit, because this feature will reduce the influence from outside. That means with a conic measurement area, you have influence by wind, which is done, which can change the measurement of the sensor itself, but also other obstacles like moving trucks, moving vehicles, plants, some type of trees can influence the measurement here. So if you have a conic measurement area, the influence is higher and the risk of influence is higher. So we have reduced this risk with this new radar sensor used in the WS100. Please go back. Okay. Also, sometimes the people ask me, how is it possible to measure the precipitation type? So the type can be measured with the main information of the precipitation velocity. And you see that in the diagrams. On the left side, we have a diagram where you see the velocity of rain in this case, and also the drop size. The drop size here information is not so important here, but on the left you see that the velocity of a normal rain event is about, in average, about 4 meters per second. And that's what the sensor can measure. The sensor can measure the velocity of the drop, and then he can classify this in a table. So that means, for example, 4 meters per second is rain in this case. On the right side, you see the same thing for snow. And if you check the velocity of a snow event, it's in average about 1 meter per second. And that's how the sensor can classify the different precipitation types. All right, so again, so the new things here for the WS100 are a new radar sensor. So also the radar sensor has changed. We have now developed a special Lufft developed sensor here, radar sensor, which we use. With this radar sensor, again, we can create a special measurement area. In addition, we have optimized the housing here. You see that. If you compare that with the old one was a dome type, and this one is more like a cylinder type of housing, which will also help to change this measurement area again. So that means the housing has changed too. We have optimized the housing here. Then we have implemented the lens to focus the measuring beam. And you see that on the picture below. Inside the WS100 you have this lens, and this lens will help to focus the beam so that we can create a straight measurement area. Another new thing is the heating, which is now directly connected to the dome wall, so that we really heat the whole dome wall, and no snow and ice can influence the measurement here. So in normal mode, so if you power up the sensor in normal mode and you use it in normal operation mode, then the sensor power consumption will be about 9 watts. And I explained it before. If you want to use it also with solar power, you can do that. So that means with solar panels and battery packs, and then you can use an eco mode. And with the eco mode in use, you can reduce the power consumption down to 0.4 watts, which is very low, by the way. So, of course, if you do that, you have some restrictions. For example, the heatings or the heating of the sensor will be switched off, of course. And how the eco mode works is that in general, the radar sensor is also switched off. Every minute, the sensor will wake up for 5 seconds and check if there is a precipitation event or not. If there is a precipitation event, then the sensor will stay switched on and measure through the whole precipitation event. If no precipitation will be detected, of course, the radar sensor will switch off again. And that's how it works. So that means with this eco mode, we will be able to reduce the power consumption to 0.4 watts. So again, some comparison slides here. First, on the left side, you see some smileys, yeah, and with the smileys, we want to show you if this information or this action is done well by the sensor or not. So that means the measurement accuracy, if we compare that with the R2S, the measurement accuracy was not so good for the R2S, again, because of the conic measurement area and the inference from outside. The maintenance frequency, you see that we have a green smiley here, is very good. It's the same like for the WS100, by the way. So there is nothing more to do here. And below we have the influence of wind, and again here we have a yellow smiley. It was not so good. The reason is again the measurement area, which was conic, and so also the wind had some influence here. So for the WS100, you see the smileys are all green. Of course, we optimize everything. We try to do that, of course, to have a better sensor now. And for the measurement accuracy, we improved the version. Again, compared to the R2S, we have now an accuracy of plus minus 10%, which was checked in our special Lufft test system here. So that was the reference here. We have a low response threshold, and that's also a new feature here. We have now the possibility to classify different drop size classes. We have 11 of them. So that's a new feature of the WS100 compared to the R2S. The R2S has had not the possibility to give you this information. The maintenance frequency, again, is the same like for the R2S. We have no maintenance, or no maintenance is required here, and we have the low energy consumption in addition. And also because of the new measurement area we generate now with the new radar sensor, we have less influence of wind on the measurement here. So we have the technical data table here. I don't want to talk a lot about this one. Anyway, you can check that in the WS100 manual. Maybe some parts on the left. We have the interfaces again for data transfer. So we have the RS485 semi-duplex interface, 2 wires that. We have, in addition, the possibility to connect the sensor in SDI12, in UMB, of course, in Modbus, and that's also an extra thing. There is also an analog output. That means the sensor will also be able to give you a pulse signal here, so you can also connect the sensor directly, for example, to a data logger in with an analog connection type. Okay, connection options and calibrations. So we will talk about the connections here, and you see that if you know that, sorry, I forgot one very important thing, because we have some nice technical tricks and gadgets here. So I want to show you now the sensor live with our special camera here. So you see the sensor here lying on the table, and you see my hand. So you see that the sensor is not very big, right? So my hand is not big and the sensor is also not very big. So it's a really smart small sensor. You can connect this sensor to a pole, and we have the fixing adapter here. That's the standard fixing adapter for the WS sensors we use for all the different WS sensor types. And the pole diameter which can be used with this adapter is between 60 and 76 millimeters. If you want to fasten the sensor, you can use a standard wrench type with the size 13 here. And so you can, of course, use it and fix the sensor easily to the pole. And here, covered by the yellow cap here, you see the connector. So that means you can connect the original WS sensor cable to the WS100 here through this connector, and then you can start to install the sensor, to configure the sensor. So it's really an easy thing here. So let's go back to the presentation. So we stopped at a connection here. So if you are familiar with UMB sensors, that's nothing new for you, because the connection is a standard UMB connection. So it's really easy to set it up. So I will not lose a lot of time here. So I think we can go on here. So calibration is, of course, often a really frequently asked question. How can you calibrate sensors? In the case of WS100, I have to tell you that an on-site calibration is not possible here. The reason is, again, the measurement principle. The sensor, the radar sensor, and you heard that before, will measure the velocity of the drop and the size. And the problem here is that if you are on site and you try to pour some water over the sensor, you will not get any values, because the problem is that you will not reach the real fall down velocity of the drop which is needed so that the sensor can measure the drops. That means it is not so easy to do that. Maybe if you have a ladder which is 5 meters higher than the sensor, you can try it, but it's really complicated. So at the end, on site, a calibration is really, really complicated, and it's not so easy. For this reason, we have another possibility, because you can, of course, send the sensor back to the Lufft company. We have a rain simulator. It's called RAISY. You see that here. It's the pack name, let's say it like this, of our nice reference device. And you see also that the device itself is also very high. It's about 10 meters high, because again, we need this fall down velocity, which we have to create. And we can do that with that tube, which is about 10 meters high. So we can put the sensor below, and we can generate droplets at the top of the rain simulator. And with this device, we are able to calibrate the sensor. So if you need that, we can do it. So what are the target groups and the typical customer problems? First of all, the problems itself. So normally if the customer wants to buy a precipitation sensor, he has some needs, of course. And normally he wants to get a very accurate sensor with a high precision, of course. He needs maybe some low response thresholds to get very fast information about the precipitation event. And he wants to have a differentiation of various precipitation types. Also, a very important fact is that the customer don't want to go there very often to maintain the sensor. So also the maintenance frequency is a very important issue here. Contamination, for example, especially of the mechanical parts, and frequent maintenance is required. And again, the influence of wind. So they want, of course, no influence of wind in the measurement. So these are the typical customer problems, yeah. So what are the special or typical applications now, for example, for the WS100? First of all, we have normally three of them. The first one is traffic management on roads. So also this customer need, of course, precipitation sensors. Precipitation measurement is very important in their application. Then we have meteorological services. They also need normally very cost-effective sensors because they want to expand their measuring network with new sensors, especially in urban areas, of course, because everybody knows that. Checking the news, we have, of course, some climate changes now, and we have a lot of precipitation events now in the world which are not really normal in these days. So that's the reason why the people always need now new sensors here. Also, the hydrology and heavy rain and flood problem is a known problem in our days now, and also for this type of application, of course, sensors like WS sensors or WS100 sensors are needed. They also need cost-effective sensors to expand their measuring network, of course, especially again here also in urban areas. So the traffic segment itself is normally divided in two different applications. So the first one is the VMS station type, which is the shortcut for variable message sign stations. That means if you drive on a highway normally today, you will often meet some bridges with some signals on it, and they will give you a lot of information. And the target of the customer here is to increase with this, let's say, bridges and sign information to increase the traffic safety, to get dynamic response to current environmental conditions. Then, of course, they have to control the traffic here based on precise detection of road surface wetness, precipitation, and visibility. For the precipitation part, the WS100 is the ideal sensor here. The reason again are that the sensor is maintenance free, so the customer can install the sensor easily and he does not need to go back and maintain normally the sensor again. Then, of course, the sensor will give you a lot of different information, for example, the precipitation intensity, and of course also the sensor has short response time, so you can control the signals very fast and change the signal information very fast, also with the WS100. And in addition, the sensor will also be able to detect a precipitation type called drizzle, which is also a very important precipitation time regarding the traffic segment. The second application is a winter-related application. It's the application of the RWIS station, of the road weather information systems. And here, of course, the important information they need, or the targets for the customer here, are to recognize risk of icing, fast reaction times on weather changes, detection of actual weather data on roads and environment. And yeah, that's of course the targets of the customer. And the same thing here, the WS100 is normally the ideal sensor to be used also for our stations. Again, the reasons are maintenance free, the sensor does not need to be maintained, shortest response times, and here of course the detection of snow, ice rain and so on, which are also very important during winter time. So we have some other product information here. So what is part of the delivery? Normally if you order the sensor, the WS100 sensor, you will get Oh, oops. Okay, back. Normally, if you order a sensor, different things are included. Of course, the sensor is included. You will get a really printed manual normally, and of course, a 10-meter connection cable is also included in the delivery. In addition, you can get different accessories like our Isocon digital interface converter. That means if you want to connect the sensor to a laptop or PC or modem or anything else, you can use this Isocon, which will create a RS-232 interface. Then you can also order special cables. There are different cable lengths. For example, you can also order a 20-meter cable if you want. Then you can also get a power supply, the standard power supply from Lufft for USB stations, 24 volts for amps here. And also in addition, if it's needed, you can also get some surge protector and surge protection modules. So that's it from my side. Thank you very much. And now I will pass to my colleague Kurt here.
Thank you, Manuel, for your kind explanation about the WS100. My name is Kurt Nemeth. I am the Program Manager Precipitation and located in Kempten in the Ott Hydromet headquarters. I've been kindly invited to act as a guest speaker for that nice presentation, and I've agreed and committed, and I'm here. So thank you, Manuel. So we have a long day. We have started our first webinar early in the morning, and now we are in the second session, and we are going to serve you as a customer and to provide the various all the information which is needed to understand the WS100. So my part is to explain the different types of measurement principles and a specific application where we can use WS100. And in my introduction slide, I've made a selection of numerous different kind of instruments which can be found in the internet, of course, and they do present different types of technology which are used for precipitation sensors and instruments. Why do we have so many different technologies in the market for precipitation monitoring? And this is due to the fact that we have a wide range of specific requirements on various applications. The wide measuring range is one point. It's the requirements starting from 001 as a very sensitive threshold and going up to 3,000 millimeter per hour. This is a very intense precipitation event. And of course, there's always the question, which type of precipitation? Is it about solid or is it about liquid? We have a very high variety of annual amount of precipitation. In the deserts, we have 50 millimeters on annual precipitation. In the tropics, we have 10,000 millimeters. And we have a variety of climate zones which we have to cover and which we have to serve with our instrument. And precipitation intensity matters. The next slide shows an overview of different measurement principles. Everybody knows about the tipping bucket gauges. They are widely and globally in operation since more than 100 years in hydro and hydrometeorological networks. But in the past, they have been invented various and numerous new technologies in the last 20 years as weighing precipitation gauges, hybrids, that is a combination of a weighing precipitation gauge as a self-automatic emptying system based on a kind of tipping bucket measuring principle. Then we have the distrometers, which are capable to measure the hydrometeor size and its corresponding velocity simultaneously. And we have the WS100. This is a kind of new instrument in the market. I just want to make only a comparison on between a tipping bucket and the WS100, and just to draw your attention on the widely and globally used old instrument, I would like to say, and the new one, the WS100. The accuracy and uncertainty of liquid precipitation is very important for the most of the users. And if we look into the typical bucket precipitation gauges, we figure out in the leaflets that there is a specification of plus minus 2% or more, or maybe better, but under laboratory conditions. The intensity error is not always mentioned in the leaflet, but I would like to speak about. So as the intensity rises, it happens that the tipping bucket system does not work properly with a resolution of 0.1 millimeter. So the bucket tilts more frequently than and that rises finally to a called intensity error. And you have to know that this intensity error can be up to plus minus 20% in high intensity rates. So coming to the WS100, also we do speak about the uncertainty. And as Manuel has explained, we do measure the hydrometeor's velocities and correlate it to the size. And finally, we do calculate and cumulate each individual water equivalent of each drop to an intensity of precipitation and cumulative precipitation. Thus, this technology has a kind of uncertainty which we do specify with plus minus 10%. Then another issue is the maintenance. The tipping bucket gauges can be are prone to debris, and finally that results that you have to clean it at a regular base. The WS100 has not such a is not prone to any debris or to any contamination, and that means there's non-maintenance. You have to install the instrument and receive the data. The measurement uncertainty for solid precipitation is also an issue for tipping bucket gauges because there is a funnel which is going to be heated, and the solid precipitation has to melt down and turned into liquid precipitation by electrical energy. That usually results in the evaporation loss of plus minus 20%. The WS100 is also somehow prone has a weakness to measure solid precipitation because it has only the information of the velocity of the hydrometeors and has not the information of the specific water equivalent of the different types of solid precipitation, and therefore we have to expect a higher uncertainty in the range of plus minus 30%. The threshold or the sensitivity from tipping bucket gauges is usually referred to the volume of the bucket itself, and for example 0.1 millimeter. And finally, that results in the sensitivity and intensity of 0.1 millimeter per hour. The WS series is more sensitive, and he's going to start with 0.01 millimeter per hour. Then the total cost of ownership or the data availability is also a difference between these two types. We have a relative high total cost of ownership for a tipping bucket gauge and a low data availability of 80% compared to a WS100 with a very low total cost of ownership and data availability of 100%. So the fields of application, I've made a ranking of fields of application, and finally we see that all these different technologies which I presented are also represented in hydro and meteorological networks, and the radar is one of the sensors which can be used in new trends and in hydrometeorological networks, especially for a flood warning system, and especially in urban areas, and as well as in automatic automation and agriculture methodological application. Each sensor does perform and measure at a site as a point measurement. But what we need is a combination of spatial and temporal information coming, for example, from a weather radar system in combination with the accurate point measurement of the precipitation stations. And both information will give a composite information, which is very important. And we have made our mind, and we have put the question, why do not combining weather radar based on, for example, dual polarization, C-band or X-band Doppler radar system with a radar precipitation sensor to measure and to correlate punctual precipitation within a high density measuring grid. Why this is important? If we refer to an urban system, it's commonly based on precipitation and drainage or discharge, and each urban system where we live is prone to extreme precipitation and to flood events. And of course, that is a threat to human lives and properties. And the issues are increase in frequency and intensity of the extreme weather and convective rain events, the impact of storm, hail, thunderstorm, and heavy precipitation on buildings and facilities of the urban system, and the fallen precipitation flows off superficially as soon as the precipitation intensity exceeds the infiltration rate of the soil. We need to know the nowcast and forecast of spatial and temporal distribution of the precipitation event to control the discharge model. And in second instance, we need to know the historical data in order to be able for improvement on infrastructure and channel system, for example, to plan and to construct adequate retention basins, infiltration system and storage system. And in both cases, we need to know the truth data of the composite information. I've attended a seminar last week, and there was a presentation of the German Weather Service done by Dr. Tanja Winterrath. And thanks to in courtesy of the DVD and Dr. Tanja Winterrath, I'm proud to present some slides or to some illustration of that presentation, and it's about Radolan. Radolan is an online adjustment of the radar data. Why we do need that? So the online adjustment performs the scan and the scan and radar image measured by the radar reflectivity and the processed intensity rates to compare to precipitation ground data. Mapped and correlated geodata of radar image scan and precipitation stations allow different method of adjustment, like a differential method or a factor method. And the intelligence system of the Radolan and software will apply appropriate the method. And finally, that results that adjusted radar data can be used to improve the quality of the precipitation runoff and discharge model and simulation. Another application is the offline adjustment, and here we see on the illustration some pictures which shows a ground-based information on a precipitation event, and the ground station in this regards has measured 53 millimeters per day. But that was not really the truth of the complete precipitation event on that area. The next picture is a Radolan online calibration picture, shows that the center of the precipitation event has measured maximum 150 millimeter per day, but that was not the truth. And the offline mode of the Radolan system shows, by using additional precipitation gauges, which has been located in the center of the precipitation event, that the annual precipitation on that day, or the daily precipitation on that day, was 292. So you see a big difference between the measured data from a punctual precipitation gauge, from the online calibration, and from the offline calibration, which includes, in addition, more sensors that are existing in the regular DVD network. That means an increased or sufficient number of precipitation sensors supports the spatial resolution of the radar systems and improve the spatial corrected precipitation data. As you see here, so the representative measurement network grid equates to precipitation station distance from 5 to 10 kilometers in urban areas. If we look to the new resolution of 1 square kilometer, it is supposed that we need more than these stations. And as already Manuel has explained, how we can afford it by using a sensor which is cost effective and requires no additional maintenance in order to reduce the total cost of ownership. And okay. Another example is we have provided a pilot project to the city of Copenhagen. We have deployed a system based on rain radar software and dual polarization X-band weather radar, and the odd particle as a distrometer. And the odd particle provide DSD metrics, drop size distribution metrics, and it's calculated data like radar reflectivity and intensity of precipitation. But finally, we figured out that we need more sensors in addition to the deployed distrometer Parsible 2. Another very nice aspect is that these kind of weather radars only weigh 68 kilogram and their size is only 100 centimeter in diameter. So they can be mounted on existing building and they do not require additional infrastructure to build. They cover a distance from 30 to 50 kilometers and their maximum resolution is 50 meters, which is quite impressive. Again, coming back to the 5 major types of precipitation sensors, we have rated them and we see the trends in which application they will be used in the near future. And coming back to the radar sensor, it's not designed and not developed to be used in the meteorological network when considering high accuracy or when considering highest accuracy. But this sensor is very suitable in hydrological meteorological networks and the traffic control systems, in the agrometeorological systems, and in the urban application. This slide shows only the comparison data or the technical data in comparison to others. So I would like only to draw the attention to the accuracy again. So be aware that the accuracy of the WS100 is a little bit less than the others, but it has no maintenance, which has to be done usually by the tipping bucket gauge. And in the last column, you see also a price range for first information. Coming to a summary of our presentation. So the result or the summary for the WS100 is the precipitation and amount and intensity is in the range of 0 to 200 millimeter per hour. This is compliant to Europe zone, and we have the type of precipitation provided by the sensor, and it's capable to distinguish between rain, drizzle, snow, freezing rain, sleet, and hail, and no precipitation according to the sign-up 4677 table. It provides an additional 11 drop size classes with a bandwidth of 0.5 millimeter, but be aware the measurement uncertainty for the rain is greater than plus minus 5%, which is commonly specified in the WMO guideline number 8. It's a very cost-effective instrument to increase the network density, and it's designed for installation in urban areas. And probably the calibration adjustment with the reference precipitation station relativizes the individual measurement uncertainty of the radar principle. So as a summary for some sales arguments, I think I do not need to read them. Everything is already said because I've seen that we have a lot of questions, and I just want to jump into the questions and provide answers by Manuel and by myself.
Okay, so let's go through the questions. First one is, how do you avoid the influence from birds or bird poop on the top of the sensor?
That's a nice question, by the way. So, at the end, there is no special thing which you can do, but our experience with the R2S was that because the sensors anyway installed outside with rain, normally the sensor will clean up itself. So this, let's say, dust or pollution of the sensor is not a real problem. So we never had problems with such things. So at the end, the sensor will be washed by the precipitation outside. So that's funny, but it is like that.
And due to its design, it's not very attractive for birds.
Anyway, that's right, because it's normally the heating is very strong, and so if the sensor is heated, it's too hot for them anyway to take place on the sensor. So normally, I think this is not a real problem.
Okay, next one. How often should a calibration be done?
That's a good question. At the end, that's always a question for the customer. It depends on the application itself. Normally, the sensor will be calibrated and checked in the company before delivery. And then normally you can use it without a recalibration again. But depending on the application again. For example, if we talk about traffic applications, that in the traffic segment, they need to be sure that the values are correct starting before the winter starts, for example. And so normally they will do a check before the winter starts every year. But that's a special traffic application problem in situation. So normally it depends. I would maybe say if you want to check it again every 2 years, this will be a good time cycle.
Next one is, what height do you recommend for installation?
So the installation height, if you check our WS100 or WS sensor manual, the height we recommend is 4.50 meters. But this 4.50 meters is only the recommendation again because of the traffic application. That means, remember, the measuring principle of the sensor, of the radar measurement, is that you will measure the velocity of the drop and the size of the drop. But of course, the sensor will also measure other velocities. So at the end, the installation height depends on the situation on site. if you have no influence from above or from the side, you can also install it at 1 meter, no problem. But you have to be sure that nothing will influence the measurement. Influence, for example, is that maybe you install it at 1 meter and everything seemed to be okay because there is nothing around. But after 3 months, a plant is growing up, and the plant will, of course, maybe influence the measurement here. So again, the installation height depends on the situation on site. Our recommended installation height related to the traffic application is 4.50 meters.
There's one question about how it is in which, the WS100 is the precipitation is measured in millimeters.
Yes. So if you are familiar with the UMB technology, and of course the WS100 is also a UMB sensor here, then maybe you know that normally this type of sensors will give you a lot of different channels. And of course, the millimeter channel is part of the WS100 channel table. So you have to check the channel table in the manual here, and you will see that the WS100 will give you a lot of different values. For example, the precipitation quantity in millimeters, also in liter per square meters, also in inches. So there are all different channels. Normally we have implemented all the necessary channels for the customers here. No problem.
One more question. So if I'm testing the rain sensor in my shower, I can expect that it will measure no rain.
Yes, that's true. You will normally not measure any type of rain in your shower. Maybe if your shower has a height of 5 meters, maybe you can do it. But then in this case, you have to put the WS100 to the ground and you have to go up 5 meters above the sensor. So again, it's the same problem I explained before. What you have to create is the minimum velocity, the drop velocity, and that's not so easy. And that means that normally the height is a problem here. So if you have the possibility to set up the sensor and yourself in a special height, you can do it. But again, then you have the problem that you have to know the water amount, how much water you want to pour over the sensor. It's not so easy. At the end, we can do it with our rain simulator, but on site it's not so easy. By the way, what you can do is, and that's the only thing you can really do on site, you can really make a check if the radar sensor is working or not. In this case, and that's what I recommend, you can use a small metal ruler, here in a distance of 5 centimeters above the sensor, and then you have to wave very fast. Because the sampling rate of the sensor is 1 minute, you have to wave minimum 1 minute over the sensor, and after 1 minute, normally the sensor will switch to rain. In this case, you know the radar sensor is working. So that's like a function test. This can be done, but not a real calibration. That's not possible.
What about the protocol and the infrastructure for communications requirements?
I do not really understand this question. So it's a 2-wire, the standard interface we use is a RS485 2-wire connection type. So at the end, you need to set up a controller, a converter which can use this type of communication. That means normally 2-wire, SDI12 is a 1-wire communication. Also, this is possible, but you have to switch to the protocol. And this can be done with the UMB config tool, with the configtool.net for the WS100 here. And then you can switch to the protocol. So that means in the beginning you have to connect it in RS485. Then you can switch the protocol, and then you can connect it to your system. That's how it works. So again, the protocols implemented in the sensor are UMB binary, UMB ASCII 2.0, SDI12, Modbus, and XDR, which is a part of NMEA protocol. Maybe another thing to the protocol. Sometimes you have to know that the non-Lufft protocols are like a service from our side to the customer, so that they are able to connect the sensor also to different systems. It's a service from our side. We have implemented these protocols so that the people can also work with other systems here.
With which kind of data logger does the sensor work?
Yeah. So again, that's a question of the protocol which is supported by the data logger. It's in general it's the wrong question, because we have these protocols, we have these interfaces. So all these interfaces we have can be connected to a data logger which have the same interface. All right, you have only to compare the interfaces, and then it will work.
Is the heating constant, or can it be set to heat only when ice or snow is detected on the sensor?
Okay. First of all, I only mentioned the echo mode before, but in reality, you can also configure the heating separately if you want. The configuration, like mentioned here, is not possible. But what can be done is you can create a threshold with the temperature. That means you can set up the sensor for 5 degrees, and then the sensor will switch off or on depending on the outside temperature. That's possible. Yeah. There are different modes, by the way. You can configure the heating in different modes. For more information, you can check our manual. All the different modes are described there, but you have different options here.
Maybe one more. What ways would you recommend reducing the effects on wind influence on measurements for WS100?
There are no ways to reduce the existing influence. So we have reduced the influence anyway with the new design and with the new measurement area created by the new radar sensor in the lens. That's the maximum optimization until now. So there are no other ways from outside to reduce the risk or the wind influence, for example. The problem is that the sensor itself will only measure the precipitation. There is no possibility to measure the wind, so that we have maybe a reduction of the wind measurement here, but that's not possible. At the end, we have done everything what is possible until now. We are always working on further improvements, of course. So let's see. But until now, that's the maximum.
Okay, we have so many questions. I think it's better to answer them via email.
Yeah.
Which we will do within the next few days or tomorrow. So everything will be answered.
Yeah, I think we will individually answer all the questions from you, because we have a lot of participants here and a lot of questions, by the way. I think we will not bother you with all the questions, about 4 hours now. So we will answer all of them, and we will send these questions to you. No problem.
And you will get a record sent via email, like I said at the beginning. So if you missed something or want to watch it again, it's no problem. You will get the information from us. So I think now it's time to say thanks a lot for your participation. And I wish all of you a great rest of the day, and hope to see you soon in the next webinar. So bye-bye to all.
Bye-bye.
Bye-bye.